in next class we will be discussing about the construction of TXY diagram. However, we have discussed this algorithm. We'll separately try to solve a problem using these equations. I'll give you a system and you'll be able to do that. So we'll spare some time in the next class. We'll be discussing about how to construct TXY diagram and what are the issues associated with that. The next important thing will be, this I think will cover, at least will require, one entire class. So then since on the same day we have another class, we'll be discussing about what we are going to discuss in that class as well here. So, the important aspect of next particular thing is a PT diagram. Like we have discussed PXY diagram, we have discussed TXY diagram, and the third category is PT diagram. So PT diagram is one where our composition is fixed. So this is for one composition, this is for another composition, this is for third composition, this is for fourth composition, this is for fifth composition. So every line represents one composition. So PT diagram of a pure component we have already seen in previous semester. Here the PT diagram is being drawn for a binary mixture, and for binary mixture there are some differences between pure component and this. As in, the critical points are this. So this is a locus of critical point, and near critical point some phenomenon which is taking place, which is very different from what generally we see, and we will discuss that as we proceed further in the same class. This solid line is your saturated liquid line, which is a bubble point, and the dotted line is saturated vapor. So as you can see at point A and B, solid line, that is saturated liquid line of one composition, is interacting with the the line of saturated liquid line of the other composition. So likewise A and B are that, and we'll discuss what are these A and B. They are basically equilibrium point. If I expand these nodes near a critical point, this will happen, and there are three things which we should know. One is critical point, other is maximum condenser or a Greek condenser point, and maximum condensed bar or Greek condensed bar point, and we will discuss about what is the importance of these 3 points, because based on this 3 point there is something which is called as retrograde phenomena which will take place. So we will be able to see that as you decrease pressure, rather than vapor generation, liquid will be generated. Increasing temperature will decrease the vapor content, or increased temperature will increase the liquid content, which this kind of phenomena are taking place in earth crust. While we are exploring the petroleum, this kind of phenomena will take place. However, our common industrial processes are way away from critical process, and they don't show this kind of inversion in condensation. So this is something which we are going to discuss at a length, and then maybe we will, if time permits, we'll discuss about non-ideal issues. Thank you.